Hey guys, Mr. Catlin here with your virtual lesson for Monday. We're going over lesson 4.5. In this lesson, we're going to be looking at these increases and decreases by fractions, and we're going to do some diagrams, and we're also going to do some equations that match up with it. So the first thing I've got here for us to look at is this table that we're going to fill out of all these situations with Jada and the things that are around her. And it's going to have us find the total distance that each one of these things walked. So let's start with Jada's pet turtle. Walked 10 feet and then half of that length again. So if you look at all of these, all of them are set up the same way. Baby brother's going to go 3 yards and then half of that again. And then Jada's hamster is going to go 4.5 kilometers and then half that again. And then the robot's going to go a mile and then half of that again. A person's going to walk X meters and then half of that again. So we're going to start this off with a diagram. Okay, so we're going to do this with just a general amount of distance. So we're going to kind of focus on this first part right here with the person that walked X meters. All right. So we're going to say that this distance is unknown to us. It's X meters. All right. And we're going to go half of that distance again. So we're going to split this distance up into 2 equal parts. And that would be like doing this. All right. So there's that distance cut in half. And we're going to do something called a tape diagram. It's very similar to a double number line, but these are actually equivalent. So it's not like ratio proportional or anything like that. So we're going to look at the total distance that this actual thing or person walked in meters. So we're going to draw, it went that entire distance, right? And then it went half that distance again. So it went this far after that, which this is equivalent to that. Okay. So this little extra that I added on is half of whatever X is. So for example, in the first one, if X is 10, if this is 10, and then I go an additional half of 10, which would be an extra 5, then that means that this right here, this total distance would be 15 because half of 10, 5 plus 10 is 15. So that's pretty easy. Now imagine the baby. If the baby goes 3, if the X is 3, if this is 3 yards total, and then the baby goes another half of 3, well, another half of 3 would be 1.5. So 1.5 plus 3 would be 4.5. So you can see how that sets up. Now this next one's a little bit tougher because it has a decimal involved in it. So imagine that this is equal to 4.5. If this is 4.5, half of 4.5, we would have to divide that number by 2, and that would give us 2.25. This would be 2.25. So what would 4.5 plus 2.25 equal? Well, when you add those together, you get 6.75 or 6.75. And you can clearly see that from this example that I drew here. All right. And then 1, if you have 1, and half of 1 is a half, so add 1.5, and that would give you 1.5. You get the idea. All right. So the question is, what are we doing to this first number to get the total distance? Well, there's a pattern here. We're finding half of whatever X is, and then we're adding that to itself, right? So a way to write that in terms of X is we're taking X, which is this value right here. This I'll shade it in red. We're taking X, right? We're taking that amount, that initial amount. We're cutting it in half, and we're adding that to itself. So we're adding X to a half of an X, right? That's one way that we have to describe what we did there. Now, there are other ways to compute these distances, and that's what we're going to really get into here toward the bottom. Another way that we could have computed that distance is we could have noticed, if we would have looked at this relationship, we would have noticed that we divide all of these, we actually have a constant of proportionality, and you see it clearly right here. What do I multiply by 1 to get 1.5? Well, I multiply by itself, right? 1.5. And 10 times 1.5 is 15. 3 times 1.5. 4.5 times 1.5 is 6.75. And then so on and so forth. So what's another way we could have written this? We could have said, instead of x plus a half of x, we could have just said 1.5 x. We actually could have thought of that as 1x plus a half of x, combined them to make 1.5 x's. Another way to think about this that's really going to be helpful for us moving forward is that this x is now a total of not just one whole x, but if we count these out, and I'll do this in blue, we have 1, 2, 3 half x's, or 3 halves x, which, by the way, is the same as 1 and a half. 3 halves is equivalent to 1 and 1.5 x. So they are the same thing. All right. And that's what we want to be able to get out of this, because later on in this, it's going to say, hey, well, May wrote this equation, x plus half of x is y. And we wrote that at the beginning. But Kieran, he came by and wrote this one, which is the same thing as using 1.5 times x. And they both work. They both work in this scenario. And so we're going to write different expressions to represent the same scenario, as you're going to see in the next example. Okay, so one more example and we're done for today. I know this one's kind of a little bit longer, but it has a lot to it. Okay, so let's look at part B of today's lesson. We're going to look at this problem. We're going to create a diagram and we're going to write an expression, and we're done. Okay, Billy spent $80 at his first store when he went Christmas shopping. Okay, $80 at the first store, and then he spent 1/4 of that at the next store. All right. So let's set up a diagram to show what Billy spent. So Billy spent at the first store, let's use this tape diagram. This is how much he spent at the first store, and we actually know what that equals. We know that that is $80. And then he goes to the next store and he spends 1/4 of that. So we're going to split this $80 up into quarters. All right. And I'm going to draw this next box to represent how much he spent all together. Okay, so all together he spent everything at that store plus an additional 1/4 of what he spent at that store. So think of like taking one of these and attaching an extra one on at the end. So our question is, how much is he spending all together? Well, we know that each one of these is worth 20, because 80 divided by 4 is 20, 20, 20, 20, right? So every one of these is worth 20, right? 20, 20, 20, that makes 80. And an extra 20 means that he spent $100, including the extra 1/4 of his first visit, right? So he spent $100 altogether. This would be his total spending, right? But what I'm more concerned about is an expression that represents that based upon what 80 is. Okay, so ways that we could express that other than just saying 80 plus 20 equals 100 is we could say things like, well, 80 plus 1/4 of 80, right? So 1/4 times 80. We could do it like we did on the last problem. We find the total, we add 1/4 of itself. That would give us 100, right? Another way to express this is to not think of it as taking a whole and adding 1/4, but to think of it like I did a while ago, with this being 1, 2, 3, 4, 5 quarters. So another way to write this would be 5 quarters times 80 is 100. And what we're really going to get into tomorrow is we're not going to think of this as 5 quarters. We can actually put this into decimal form. And this looks like this. 5 quarters is $1.25 times 80. And that would also be 100. So you see how all of these match up, and they are all the same thing, just expressed in different ways. 5 quarters is the same as 1.25. A whole plus 1/4 is $1.25. So that makes sense there to write it out like this. These are just different ways to express the same thing. And what we're really getting to, and this is going to get by the end of the week, is right here. This is the key, is that this is a 25% increase. And you can clearly see the 25 in this percentage right here. 125% is a 25% increase. So that's where we're going by the end of the week. All right. And that's all I've got for this video. This should help you get through the cool down today. You can look at this and watch it, and hopefully it will be helpful to you. Y'all have a great week, and just email me if you have questions or trouble.